Hello students, heartiest greetings of the day. Today we will be continuing practice set 1.1 from where we had stopped earlier, that is from sum number 3. Just see that video before going to this video and note down and understand the concepts that were taught there because that will be useful in these sums as well. So we move to question number 3, but before that we'll get the introduction of this chapter, that is the basic concepts in geometry, standard 9 maths 2 chapter number 1, and this is the second part of this chapter which will contain sums from practice set 1.1 sum number 3 to 7. This is the continuation of the first video. So let's get started with question number 3. Question number 3 reads, from the information given below, find which of the point is between the other 2 points. If the points are not collinear, state so. That means if the points are collinear, find their betweenness, that which point is between the other 2 points. And if the points are not collinear, so definitely there will be no point in between other 2. So if the points are not collinear, we have to state that as well. So we'll see how to solve such type of sums. So our first question in the textbook is, distance PR equal to 7, distance PQ equal to 10 and distance QR equal to 3. Now we'll see how to solve this sum. First of all, write down all the distances that are given in question. Distance PR equal to 7, distance PQ equal to 10 and distance QR equal to 3, and give a flower bracket like this and write it as given because it is already provided to us in the question. Now you all will say that what is the reason to write this thing? Because you all don't write question in exams, you all will mention the required data in the solution itself. After that, check the values of all three distance. Now which of these numbers is greater, 7, 10 or 3? 10 is greater. So for time being, ignore distance PQ. Don't look at this. Look at distance PR and distance QR. Now, the largest value of distance, apart from that, whichever two other distances are given, we'll add both of them. So we'll add distance PR plus distance QR in the next step. Distance PR is 7 plus distance QR is 3. 7 plus 10, 3 equal to 10. Correct? Now, you all will have to compare the addition of remaining two distance with the value of the bigger distance. In this case, the largest distance is distance PQ and distance PQ's value is also 10. So we'll mark this statement as number 1. We'll mark this statement as number 2. And what we can say from statement 1 and 2? That distance PR plus distance QR ka value, that is 10 units, is equal to the value of distance PQ, which is also 10 units. So distance PR plus distance QR is equal to distance PQ. Whenever we get this measurements equal, we can say that the points are collinear. Now which points are repeating in this question? P, R, P, Q and QR. Basically only 3 points are there, that is P, Q and R. So what we can say is points P, Q and R are collinear. Now how will we know that which point is between the other two? Look at the largest distance. Largest distance is PQ, correct? Which point is missing here? Point R is missing. So R will be between P and Q. Understood? So whichever point is missing in the largest distance, the value, that point is between the other 2 points. So in this case, we'll write point R lies between points P and Q, and betweenness will be represented as P dash R dash Q, where R is between P and Q. Understood? So what we'll do here is, we'll write reason here. Therefore, from 1 and 2, and we'll make a box to this statement whether it is collinear or not collinear. Understood? So this is how you all will attempt the sum. I'll repeat the steps. First of all, write the given distances in the sequentially descending, write it in a manner it is given in the question. Analyze which is the biggest distance. So in this case, distance PQ equal to 10 units is the biggest distance. Ignore that and look at the other two smaller distances. Add the two other smaller distances. You'll get an answer. Compare that answer with the largest distance. In this case, it is distance PQ. If both of them are same, we can write that from 1 and 2, distance PR plus distance QR equal to distance PQ. If it is equal, points P, Q and R are collinear. If this is not equal, these points will not be collinear. If these points are collinear, look at the biggest distance, that is distance PQ. The point that is missing in this will be between the other two points. So therefore, point R will lie between points P and Q. So now I'll show you all one more sum. Sum number 2. Distance RS equal to 8, distance ST equal to 6 and distance RT equal to 4. Let us solve this sum also. In this sum, we'll again write all the three distances provided in the order it is given in the question. We'll make a flower bracket and we'll write given. Okay. Now again, which is the biggest distance, 8, 6 or 4? 8 is the biggest distance. It is of distance RS. Ignore this part. Add the other two distances. So therefore distance ST plus distance RT, which is 6 plus 4, which is equal to 10. Mark this as number 1. Now compare it with the biggest distance, that is distance RS. Distance RS is 8 units. Mark this as number 2. So what we can write is therefore from 1 and 2, distance ST plus distance RT, whose value is 10, is not equal to distance RS, whose value is 8, because 10 and 8 are not equal. So distance ST plus distance RT will not be equal to distance RS. So therefore, points R, S and T are not collinear. If the points are not collinear, there doesn't even arises a question of betweenness. So because when points are non-collinear, no point can be between the other two points. So hence, this is our final answer, that points R, S and T are not collinear. Now I have shown you all one sum for collinear, one for non-collinear. Try out question number 3, 4, 5 and 6. Verify your answer with the solutions that I am displaying and try to practice it on your own and try to solve them on your own. Question number 3. Distance AB is 16, distance CA is 9, distance BC is 7. Solution. We'll write down all the three distances, 16, 9 and 7. Mark it as given in a flower bracket. Ignore the greatest value of distance. So distance AB equal to 16 will be ignored. Remaining two distances you all add. So that is distance CA plus distance BC, which is nothing but 9 plus 7. That is equal to 16. Mark this value as number 1. Compare it with the largest distance, that is distance AB, that equals to 16. Now if you look at both the values, so what we can say, therefore from 1 and 2, you all can see distance CA plus BC, that is 16, is equal to distance AB, which is also equal to 16. So therefore we can say that points A, B and C are collinear because the answer is equal. Both the answers are same. If points are equal, check the biggest distance. It is distance AB. So point C is missing. So point C will lie between A and B. Betweenness can be given as A dash C dash B. Now some students ask a question, can we write it as B dash C dash A? Yes, it is fine. Order of the extreme points is not important. Only order of the point in between is important. Because even if you change the extreme points, it doesn't make any considerable difference in the figure. Okay. So writing BCA is also fine, but we'll go in order only, the way distance is given here. But if you even if you write B dash C dash A, it is totally fine. We'll move to question, mark this as final answer and move to question number 4. Question number 4 is distance LM equal to 11, distance MN equal to 12 and distance LN equal to 8. Again the same steps. Write all the three distances in the order it is given in question. Add the two smaller distances, ignore the bigger one, that is distance MN will be ignored in this case. Add the other two, that is 11 plus 8. 11 plus 8 is equal to 19. Mark this value as number 1 and compare it with the biggest distance. Now biggest distance is distance MN, which is 12 units. Now if you look carefully, 19 and 12 are not equal. So therefore distance LM plus distance LN will not be equal to distance MN. So if it is not equal, that means points L, M and are not collinear. If points are not collinear, then there doesn't even arise a question of betweenness. So this sum is over here. Let us move to sum number 5. Sum number 5 is distance xy equal to 15, distance yz equal to 7 and distance xz equal to 8. Now in this case also in solution, we'll write all the three distances in sequential order. Ignore the greatest value of distance, like your distance xy equal to 17 will be ignored. Add the remaining two distances, that is distance yz plus distance xz, that is equal to 7 plus 8. 8 plus 7 is equal to 15. Okay. Now compare it with the greatest distance, that is distance xy. It is equal to 17. This will mark as number 1. This will mark as number 2. So therefore, from 1 and 2, we can say that distance yz plus distance xz does not equal to distance xy. So therefore, points x, y and z are not collinear. Here I have written it by mistake that it is collinear, but in reality they are not collinear. Okay. So ignore this statement also. This should not be written. This will be your final answer. Oh, sorry. Actually, here the value is 15. Extremely sorry. Take this as 15, 7 and 8. Yeah, then you all will get the answer as collinear. Yeah, there was a mistake above actually. No, this is correct. This value will be 15. Sorry for the mistake. So just verify it here. It is collinear. It is correct. Okay, so points x, y, z are collinear. As greatest distance is distance x, y, z is missing. Z will be between x and y. Let us move to sum number 6. Sum number 6, distance DE is 5, distance EF is 8 and distance DF is 6. We'll write them again in sequential order, 5, 8 and 6. Greatest distance is distance EF, that is 8. Ignore it. Add the other two distances, that is distance DE plus distance DF equal to 5 plus 6, that is equal to 11. Mark this as number 1. Then distance EF is 8. Now 8 and 11 are not equal numbers. Okay. So therefore, we can say that from 1 and 2, just a minute. Okay. Distance DE plus distance EF is not equal to distance EF. DE plus DF is not equal to EF, as both the values are different. 11 and 8 are different numbers. So therefore, points DEF will not be collinear, and if they are not collinear, there doesn't even arise a question of betweenness. Okay, so write this down. All the 6 sums of question number 3 are over. Now we move to main question number 4. Understand this type of sums as well. Question number 4 reads, on a number line, point A, B and C are such that distance AC equal to 10, distance CB equal to 8. Find distance AB considering all the possibilities. Now remember, A, B and C can be arranged in three ways. As we all have learned, betweenness can occur in three ways. I'll show you all the three ways. Like A, B is between A and C. In second case, we can write C is between A and B. And in third case, we can write A is between B and C. Just a minute. Okay. So first of all, what you'll do, draw this in rough and check it. Now put the distances. Distance AC means this entire thing is 10 units and CB is 8 units. So this possibility can happen. Okay. Now next one. Distance AC is 10 units and distance CB is 8. Even this possibility can happen. Now check third one. Distance AC is 10 and distance BC, that is this entire segment, is 8. Now this is not possible that a smaller part of the bigger segment is greater in value, greater in distance, and the bigger segment is smaller in distance. AC, which is 10 units, cannot be under a line BC, which is 8 units. So this possibility is not possible. So we'll not write this possibility, we'll write the other two possibility and solve the sum. So you all understood how to guess that which two diagrams or which possibilities can exist. Okay, so we'll work out our sum accordingly. Okay, just a minute, I'll rub this out. Okay, so in solution, we'll write the two distances that are given to us, that is distance AC equal to 10 and distance CB equal to 8, and we'll mark it as with a reason as given. Now possibility 1, like I have shown here. In this possibility, C will lie between A and B, that is A dash C dash B. In our diagram, A will be here, C will be somewhere in between, and B will be at the end. Now remember, AC is 10, so this is 10 units, and CB is 8, so this is 8 units. So in this case, what will be distance AB? Distance AB will be distance AC plus distance CB. Yes or no? Because bigger segment is nothing but addition of two smaller segments. So distance AB, entire distance, is distance AC plus distance CB. Distance AC is equal to 10 units plus distance CB equal to 8 units. If you add both of them, you all will get 10 plus 8 equal to 18. So distance AB equal to 18 units. Okay, so our final answer is distance AB equal to 18 units, where this condition of betweenness exists, that is A dash C dash B. We'll box it. Now remember, we had made three possibilities and out of that one was removed. This was the first possibility. Now one more possibility exists, where possibility 2, in which B lies between A and C. Yes or no? So in this diagram, what we'll do is we'll make A at one corner, B is in between, and C is at the other corner. Now in this possibility, distance AC is 10, means this entire big distance is 10 units, and distance CB is 8. CB is nothing but this part. This is 8 units. Mind it, here I am not using scale because I don't have any such kind of facility right now here which can introduce a scale in a computer. But while you all make this, please do not make freehand diagrams in geometry. Make use of scale and pencil wherever required. Okay, in this case also, segment AC will be equal to segment AB plus BC. Yes or no? Just I'll edit this out. This is segment AC, which is equal to segment AB plus BC. Okay. Now add it. Do I know the value of AC? Yes. Distance AC is 10. That is equal to distance BC, which is 8, plus distance AB, which we have to find out. Okay. So we'll shift distance AB on left hand side. that will be equal to 10 minus 8, that is equal to 2. So therefore distance AB equal to 2 units. So we'll write distance AB equal to 2 units for this possibility, that is A dash B dash C, and make a box. So you can pause the video and note this sum down. Okay, we'll move to the next question, that is question number 5. In question number 5, it is written that points x, y and z are collinear in such a way that distance xy is 17, distance yz is 8. Find distance xz. Now again, we'll draw the figures and analyze the possibilities, because distance xz can come in many ways in this particular condition. So one possibility is that x is on a corner, y is in between, z is on the other corner. Second possibility is x is in between, y and z are on the corners. And third possibility is that z is in between and x and y are on the corners. Now put the values and check. Distance xy is 17, yz is 8. So this possibility can happen. Distance xy is 17, that is this small part is 17. And distance yz is 8, means this entire big segment is 8. Now this cannot be possible. That's a smaller segment has a greater distance and a greater segment has a smaller distance visually. So this possibility cannot happen. Now check this third possibility. Distance xy is 17 and distance yz is 8. So this possibility can occur. So apart from this possibility, other two can happen. So we'll solve our sum for those two possibilities only, just like the previous sum. Okay. So we'll move further. Solution. Again, we'll write both the distances that are given to us and we'll mark it as given. Now possibility 1. What is first possibility? That point z lies between x and y, such that x dash z dash y. Now look here. Point z is in between, x and y are at the corners. Now in this case, distance xy, means this entire thing, is equal to 17 units, and distance yz, the smaller part, is equal to 8 units. So in this case, we can write distance xy as distance xz plus distance zy. Distance xy is 17 equal to distance xz, that is to be found out, plus distance zy, that is 8. Now shift distance xz to left hand side. That will be equal to greater number 17 minus smaller number 8. Now 17 minus 8 is 9. So therefore distance xz equal to 9 units for x dash z dash y possibility. Mark this. Okay. Now we move to possibility number 2. What is possibility number 2? That point y will lie between x and z such that x dash y dash z. So our diagram will be like x is on a corner, y is in between and z is on another corner. Now remember, xy is 17, yz is 8. So we can say that distance xz is equal to distance xy plus distance yz. Yes or no? Now add them. Distance xz we have to find out. Distance xy is 17. Distance yz is 8. 17 plus 8 is equal to 25. So therefore distance xz equal to 25 units. So we'll write distance xz equal to 25 units when x dash y dash z, that is y is between x and z. So how will you write this sum? You all will write this column first, then you all can write this column. It will not be possible for you all to write both of them just one beside other, because space in notebook might be a little constraining. So write accordingly. You all, I own best judge. Write the way it is suitable to you. Okay, but I suggest that you all write this down first and then leave one line and write this down. Okay, now we move further to sum number 6. Question number 5 gets over here. You all can pause the video and write down this sum. Question number 6. Question number 6 is sketch proper figure and write the answer of the following question. Now, question number 1 is if A dash B dash C and length AC equal to 11, length BC equal to 6.5, then length AB equal to question mark. Means we have to find out the value of length AB. Now remember, here betweenness is given to us. So we'll draw the figure according to this betweenness only. We don't consider any possibilities here. In earlier case, no betweenness was given. So we had to consider all the possibilities that can happen. But here betweenness is given. So we'll only consider this possibility and we'll draw the diagram. Okay. So solution. First, what is written in question? Sketch proper figure. So we'll draw a proper figure. Before that, we'll write whatever is given, that length AC equal to 11, length BC equal to 6.5, whatever is given in the question. Now we'll sketch the figure. Here it is given A dash B dash C, that is A will be at a corner, B will be in between, and C will be at another corner. Okay. Now, length AC is 11. So what you all will do? You all will mark this entire thing equal to 11. Like this, using a pencil. And length BC equal to 6.5. So this particular part you all mark it as 6.5. This is your properly sketched figure. This contains marks in this question. Now, how will you find length AB? Length C. Bigger segment is addition of other two smaller segment. So length AC will be equal to length AB plus BC. Yes or no? Now substitute the value. We know that length AC is 11. So therefore 11 equals to length AB, that we have to find out, plus length BC, that is 6.5. Now what you all will do? Shift length AB on this side. So therefore length AB equal to 11 will come here minus 6.5. So 11 minus 6.5 is 4.5. So therefore length AB equal to 4.5 units. Okay. So this is our final answer. Mark this down. Okay. So this is how you all have to solve all the question numbers in question number 6. You all can try second and third one and check it with the solutions that will be displayed here. Okay. Now, question number 2. If R dash S dash T and length ST is 3.7, length RS is 2.5, then what is length RT? Now again, we'll write down whatever is given in the question. That is ST is 3.7, RS is 2.5, etc. Now we'll sketch the proper figure. Now this is my line. Here, what is the betweenness given? R dash S dash T. So R will be here, S will be in between, T will be at a corner. Now remember, what is given? Length ST is 3.7. So this particular thing is 3.7 units. And length RS is 2.5. So this particular thing is 2.5 units. And you all have to find out entire RT ka length. So length of RT will be length of RS plus length of ST. Bigger segment is addition of two smaller segments in betweenness. Okay. So length RS is 2.5 plus length ST is 3.7. Now add the numbers. 5 plus 7 is 12, 1 will be carry, 0.2, full stop, 3 plus 2, 5 plus 1, 6. So this will be 6.2. Okay, so therefore length RT equal to 6.2. So what we'll write? Therefore length RT equal to 6.2 units. This is our final answer. So this is the properly sketched figure and this is our answer. Now we move to sum number 3. Sum number 3 says if x dash y dash z and length xz is 3 root 7, a very dangerous number as of now, and length xy is root 7. then find length yz. Okay. Now as of now you all have not learned the chapter of real numbers. So just remember that 2 root 7 can be added. If there is no number beside root 7, then you all can write it as 1. Okay, just as of now remember this thing, and root 7 will be just following the way it is. Okay, so in solution we'll write down what is given in the question, that is length xz equals to 3 root 7 and length xy equals to root 7. Now we'll sketch a proper diagram. Okay, so our diagram will be x dash y dash z. Now see, xy is not it is given to us as root 7. Yz we have to find out, and entire xz is given to us as 3 root 7. Okay, so as I have said, entire length xz will be equal to length of two smaller segments xy and yz. So therefore 3 root 7 equal to length of xy, that is root 7, plus length of yz. Now if we shift yz on the other side, this will become length of yz equal to 3 root 7 minus root 7. Now as I said you all earlier, if there is no number beside root 7, you all will write it as 1. So this will become 3 minus 1 and root 7 will be outside. 3 minus 1 is 2 and root 7 will be following here. So therefore length yz equal to 2 root 7. So you all will not write this answer, this has come by mistakenly. Length of yz will you all will write 2 root 7 unit. That's it. Okay, so I want you all to write this down in your books and understand this thing. Okay, now we move to the last question of this practice set. That is a simple one line question. See, question number 7. It is not sixth one. Okay, it is question number 7 as it is written here. Do not concentrate here. So question number 7, which figure is formed by 3 non-collinear points? Now you all put 3 non-collinear points anywhere, like I have put it here. If you all join these 3 non-collinear points, which figure do you all get? You all get a triangle, yes or no? So in solution, what we'll write? A triangle is a figure formed by 3 non-collinear points. For further reference, you all can draw this diagram and name it something, like I have named it here A, B and C, and draw it using scale and pencil. So a triangle is a figure that is formed by 3 non-collinear points. You all have to remember this thing, okay? Triangle is that figure which is formed by joining 3 non-collinear points. This is a simple 1 mark objective type of question that can be asked. Similarly, which figures can you all form with 4 non-collinear points? You all can form a square or a quadrilateral. Not only a square, you all can form a quadrilateral. So even such kind of questions can be expected. So be prepared for that as well. Okay. So with this, we end up practice set 1.1 of mathematics part 2. Thank you so much.